Alright, good morning guys. Before we start our class, let us have a prayer first. So let us put ourselves in the holy presence of the Lord as we all say in the name of the Father, and the Son, and the Holy Spirit. Amen. Our Father, who art in heaven, hallowed be thy name, thy kingdom come, thy will be done, on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses as we forgive those who trespass against us, and lead us not into temptation, but deliver us from evil. Amen. Alright, good morning. Once again, class. How are you this morning? Okay, good. Nakabreakfast ba ang tanan? Okay. Nice. Good. So right now, let us check on your attendance. Say present when your name is called. Right? Cheska, Justin, Jane, Catherine. Alright. Okay, very good. Everyone is present today. Now, I have here our classroom rules. Alright, in this class, I want everybody to be ready. So, ready stands for R, respect everyone, E, engage fully, A for act responsibly, and D for do your best, and Y for yield to growth. Alright, do we understand that? Okay, now let us recall the topic from the previous meeting. Okay, we have here a quadratic equation is any equation that can be written in the standard form. So ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a is not equal to 0 because if a is equal to 0, it is not quadratic. Okay, it is not quadratic, it is just linear. Now, we also tackled 4 methods of solving quadratic equation. First here is extracting square roots. So it is used when the equation is already in the form of x squared equals k. Then we'll get x equals positive negative square root of k. Okay. Next is we also tackled factoring. Factoring is the breaking of the equation into two binomials. Example, the x plus p times x plus q equals 0, where we will get x equals negative p and negative q. Alright. Now we are also completing the square and quadratic formula. Okay, so before we begin our proper discussion, I have here an activity. It is called luck of the draw. I will randomly draw a name from a box containing strips of paper with your names in it, and the selected student will participate by solving a quadratic expression using a given clue. Okay, so the clue is find the constant term by squaring half the coefficient of the linear term. Alright? Okay. I'm gonna pick a name, and when called, please solve it. You can turn on your mic and answer. Alright, we've got Amy. Amy, answer this expression. Alright, you got it. Let's check it first. Let's check it. Alright, we got 25. So Amy is correct. So it says the clue that find the constant term by squaring half the coefficient of the linear term. So how did you do that, Amy? Alright, so 10 divided by 2, which we will get 5. Then it says that we will square the half. Okay, so the 5, we will square it. So 5 squared is 25. Alright. So next, let's have Justin. Justin, please solve this next equation. Alright, let's check if you got it correct. Alright, you got it correctly. So the answer is 9. So since it is negative 6, we will get the half of it, which is negative 3. And when we square it, we will get positive 9. Next, let me call on Chloe. Chloe, this is your expression. X squared plus 12x plus blank. Alright, what is your answer? 36. Okay, 36. Let's check. Alright, that's still correct. Good job. So again, positive 12 divided by 2 is 6. So 6 squared is 36. Okay, good. Now, I have a question. Okay, so what happened to the expression after you added the number in the blank? What did you notice? Yes. 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 Catherine. Yes, Catherine. So, yes. Yes. The expression turned into a trinomial that looks like it can be factored easily. Alright? So, next. So, why do you think we were doing the same steps for every expression? Yes, Justin. Yes, because we were trying to make the expression into a perfect square. Okay, good. Now, how do you think this activity connects to solving quadratic equations? Yes, Toby. Because it shows a pattern we can follow to change a quadratic into something we can factor or solve easily. Alright? Now, so here's the objectives for today's lesson. So, our topic for today pala is solving quadratic equation by completing the square. Diba? The activity is about solving and completing the square. Alright? So, our objectives first is the students will recognize that quadratic equations can be solved by completing the square. Apply the step-by-step process of completing the square to solve quadratic equations. Show perseverance when solving multi-step algebraic problems. And value accuracy and logical reasoning in mathematical problem solving. Okay. Alright. Now, in algebra, now, in completing this, now in algebra, quadratic equation, from the Latin word quadratus, for square, is any equation that can be rearranged in standard form as a squared plus bx plus c equals 0, where x represent an unknown and a, b, and c represent known numbers where a negative is not equal to 0. We can also solve any quadratic equation using the method called the completing the square. So the completing the square is another method of solving quadratic equations. It allows trinomials to be factored into two identical factors. So for example, we have here x squared plus 6x plus 9. You can see it there, I'm sorry. So x squared plus 6x plus 9, you will get to the factors of it with x plus 3 times x plus 3 or x plus 3 squared. So to complete the square, it is necessary to find the constant term or the last number that will enable factoring of the trinomial into two identical factors. Okay, now let's try to find it. Now we have here the x squared plus 6x plus 9. So to find the constant term needed, simply take the coefficient of x, which is 6 here, 6x, 6 and divided by 2, which is 6 divided by 2 is 3. And then divide it by, and then square the quotient. So 3 squared is equal to 9. That's why it is x squared plus 6x plus 9. And we'll get the factor x plus 3 times x plus 3 or x plus 3 squared. Okay? Now, if you have an equation rather than an expression, the resulting number should be added to both sides of the equation. Okay? Now, let's have here example number 1. Now, example number 1 contains x squared minus 8x minus 9 equals 0. Now, our original equation here is x squared minus 8x minus 9 equals 0. So, next is we move the constant term to the right side. The constant term is the negative 9. Okay? So, we move it to the right side. So, it becomes x squared minus 8x equals 9. And then, we add 16 to both sides. The right side is, no, the left side is a perfect square trinomial. Here. Now, let's take note that to get the constant that will complete the square, take the coefficient of x. That's what I said earlier, that we also need to complete the left side first. Okay? We need to complete the left side first. Let's complete the trinomial. Okay? The perfect square trinomial. So that's why we would take the coefficient of x, then divide it by 2, then square it. We have negative 8 as the numerical coefficient. So negative 8 divided by 2 squared, thus we will get 16. That's why we added 16 to both sides to also balance the equation. Now, since we have x squared minus 8x plus 6, since we also added 9 plus 6, we also get 25 on the right side. Okay? So next, we need to factor the trinomial square. Okay? So we factor x squared minus 8x plus 6, so we will get x minus 4 squared. Alright? and again equals 25. Now next is to extract the square root of both sides. Okay, we'll get the square root since 25 here is perfect square. Sorry. So x, since we square root, we also square root on the left side. So when we square root, this becomes 5. Oh my, sorry, it is only 5. Square root of 25 is 5. And when we square root, we will remove square there in x minus 4. Here, 8x minus 4, we will remove the square. Okay, so this is only 5. So the answer is, left is x minus 4 equals positive negative 5. Now next is to equate the linear expressions to each of the two values. Okay, since we have positive negative here, ato na siyang buwagon. So we will have x minus 4 equals positive 5 or x minus 4 equals negative 5. Right? So we solve each of the resulting linear equations. So we will get x equals 9 or x equals negative 1. Since we will move negative 4 to the right side, so we will get positive 4. So it becomes like x equals 5 plus 4, that's why 9. Then x minus 4 equals negative 5. That will become x equals negative 5 plus 4 will become negative 1. Okay? Alright. Now the solution we will get is negative 1 and 9, positive 9. So let's do the checking. Let's see if negative 1 and 9 is correct. So for negative 1, we will simply substitute. The x there is the negative 1. So we will get 0. Since we got 0, that is correct. Then for positive 9, we substitute. And then if we got it 0, then that is correct. So negative 1 and 9 is correct. Now another, example number 2. Okay, example number 2, the original equation is x squared plus 14x minus 15 equals 0. Okay, now we move the constant term to the right side. It will become positive 15, then add 16 to both sides. No, sorry. Oh. So we add 49, since 14 divided by 2 is 4, and 14 divided by 2 is 7, and 7 times 7, or 7 squared, is 49. So we add 49 to both sides. Alright? And when we add 15 plus 49, we will get 64. Okay? We will get 64. So the equation now is x squared plus 14x plus 49 equals 64. Now we will factor the trinomial square. Okay? Now we will get x plus 7 squared equals 64. Now we will extract the square root of both sides, which we will get 8, and we will remove the square root. Okay? Now we need to equate the linear expression to each of the two values, which we will get x plus 7 equals 8, and x plus 7 equals negative 8. Okay? Now let us solve each of the resulting linear equations, which we will get again x equals 1 and x equals negative 50. Okay? Alright, now let's do the checking to see. Now for x equals 1, we substitute, and then we get 0, so it is correct. And then for negative 15, substitute, minus, and we get 0, then it is correct. So 1 and negative 15 is correct. Okay? Now, so again, let's recap. So again, to complete the square, it is necessary to find the constant term or the last number that will enable factoring the trinomial into two identical factors. Okay, so to find the constant term needed, we simply take the coefficient of x divided by 2 and square the quotient. Okay, alright, so understand the lesson, class? Okay, very good. Now I will group you into 3 groups. Each team has 3 shuffled set of puzzle pieces, 1 set per equation, and each team must unshuffle and correctly order the steps for each equation, solve the quadratic equation step by step using the ordered cards, and present their final answer on the board or sheet. Okay, so the first team to correctly solve will win. Okay, now I will give you 5 minutes to answer. Starts now. Alright, now, okay, time's up, everybody. Let's check our answers. Okay, now for the equation number 1, we have Okay, x squared plus 6x equals 16. So, the answer is x equals 2 and x equals negative 8. Okay, that is correct. Now, for group 2, we have x squared plus 4x minus 5 equals 0. And the answer for it is equals x equals 1 and x equals negative 5. Oh my gosh. So, next is group 3. We will have x squared minus 10x plus 7 equals 0. And the answer is x equals 5 minus 3 square root of 2, or x equals 5 plus 3 square root of 2. Okay, everybody, you got it correct. Good job. Very good. Nakuha na di ay, no? Nakuha na sa iyo na di ay. Sa iyo na siya. So, since nakuha naman, let's have a short quiz. Okay. I will only give 10 minutes to answer. Okay? Okay? Alright. Let's start now. Next, let's have... Alright, time's up. Okay, everybody. Okay, class. Good, very good kayo today, huh? So, for your assignment, as preparation for our upcoming topic on the quadratic formula, on the last 4 methods of a quadratic equation, I'll have you to identify and write down the quadratic formula, provide one example of a quadratic equation in standard form, and solve the example using the quadratic formula. Okay? You may take a picture or write it down on your notebooks or take a screenshot. Okay, done? Alright, so before I leave this class, I have here a short quote. The essence of mathematics is not to make simple things complicated, but to make complicated things simple. That is from Stan Goddard, a mathematician. Okay, class. Thank you for listening. Goodbye, and God bless everyone.